Chapter 8 is relational algebra and calculus. Please review and doing your assignment 3. In the relational algebra is equivalent with the calculus, and there's a letters relational tuple calculus will be designed nowadays SQL. Domain relational calculus is adopted Microsoft Access the query by example, the query by example, query window, query pane designed by domain relational calculus. Please review this one in order to do your assignment 3. In relational algebra, there is a unary operator, binary operator. And first unary operator, select the project, rename. The binary operator, there's union, intersect, and Cartesian product, join, division, and addition, outer join. At unary operator using sigma and relation R, and the subscript, all the condition combined, conjunctive, disjunctive condition is defined under sigma. So there's example. The project operator relational algebra using pi and apply relation R. The attribute list that's selected, they showing under the subscript in the pi algebra. And next operator unary rename, they're using row. You can rename attribute and also rename in the relation. Binary operator in the union, they can apply union on two relation. Result 1, result 2 union is result 1. If they have both SSN exists, they only include only one. Intersect operator minus operator. So union intersect is commutative. R union S is equal S union R, and also associative. So you can apply S union T and apply union R, or the same output R union S and then union T. But minus is not commutative because R minus S is not same as S minus R, just like our algebra. And next binary operator is Cartesian product. And this example, apply Cartesian product. Under the Cartesian product, we have a particular condition, joining a condition that is between relation R and S. Under join operators, this equality apply this. There are other more general theta join, which is greater than, less than. All this operator you can apply at relation between R and S equal theta join. And natural join is they found the common attribute between R and S. C and D are both exist. They compare C in R same as C in S relation, and D attribute had to be same both relation R and S. There's a natural join. There have division operators, which is R divided by S. If you look at this, X is subset of Z, and here's Y is when Y is Z minus X, which is Y is a set of attribute of R, is not attribute of the S. Let's take an example. Piano SSN divided by Smith pianos, and looks like Smith piano is project 1 and 2. So who's SSN, employee SSN, working on both project number 1 and 2? This output. So division operator, there are two SSN, two employee, are working on both project 1 and 2. So the same thing, this example, to see division operator. Here's a summary of relational algebra. In order to optimize query processing time, they're using different types of tree. So maybe each company, they different data structure to minimize query processing time. Also, the aggregate function they can add to relational algebra. A recursive closure operation, which applies supervisor, supervisee on same relation employee. And extent of join, there's outer join. This example, left outer join, and between relation, left outer join on department to include whose department not been signed, John and Alicia and Ramesh, Joyce, Ahmedis will be included by apply left outer join. If equi join, may only output equi join apply employee and relation, employee and department. They only found Franklin and Jennifer and James. So like they left outer join include who's not assigned department yet. Add a query 1. So here's add a query. Then you can express using relational algebra. So retrieve the name and address of all the employee who works on research department. So here's the play using sigma and pi in algebra. Now moving to calculus, you can express tuple calculus or domain calculus. The calculus is non-procedural languages, but algebra is procedural languages. The tuple calculus, select a tuple such as following condition is met. Example, tuple.fname, tuple.lname had the tuple belong to employee, and tuple salary attribute had to be greater than 50,000. That's expressed using tuple calculus. And also with existential universal quantifier. So universal quantifier and existential quantifier, and with apply tuple calculus. So here's an example from advch8 query natural languages. You can write using tuple calculus. Tuple calculus letter and design nowadays SQL, selected from where, or although they range of retrieve the query languages designed from tuple calculus. Now domain calculus, they focus on domain. So X1 domain is attribute, which is column. X2 had meet following condition. They select U attribute, U domain, V domain, then following this condition. So it looks like employee have a 10 attribute, 10 column, and those Q attribute had to be John, R had to be B, as it looks like last name is Smith. They meet retrieve birthday address of the employee whose name is John B. Smith. The place is domain calculus. Microsoft Access database design query by example pane, query window based on domain calculus. They pick up very graphic interface. They drop it and selected attribute by clicking the column in QB pane in the Access database. They under the attribute they filled out some condition there to meet those criteria. Query by example, they demonstrated. And also apply aggregate function in domain calculus. So please review these calculus and relational algebra for doing assignment number 3.